Lesson 6-5 is about multiplying polynomials. Monomials to monomials, monomials to binomials, binomials to binomials, polynomials to polynomials. The important thing is you have to remember your integer rules. So when multiplying like bases, you add your exponents. And so that's the one that we're going to use the most. And then when collecting like terms, you just add and subtract the coefficients. The variable string stays the same. So let's look at example 1. We have a monomial times a monomial. You're going to hear me say the same mantra over and over again. Coefficients to coefficients, like bases to like bases. So what that means is you're going to multiply coefficients to coefficients and then like bases to like bases. So 5 times 4 is 20. And then x squared times x cubed, when multiplying like bases, you add the exponents. So when you add those exponents, you get x to the 5th. Example number 2. So again, we're going to multiply coefficient to coefficient. So negative 3 times 4 is negative 12. And then like bases to like bases, x cubed times x, that's an x to the 1st. So add those exponents, 3 plus 1 makes it x to the 4th. And then y squared times y to the 5th, 2 plus 5 is 7, y to the 7th. Example 3. Example 3 is only difficult in the sense that you've got 3 monomials and you have a fractional coefficient on this one, and not all of them have a, b's, and c's. They only have 1 or 2 of those variables. So we're going to start with coefficients to coefficients. So 1/2, the coefficient here is 1, coefficient here is 6. So 1/2 times 1 is 1/2, and then times 6. So essentially 1/2 times 6 is 3. So that's the product of all 3 of your coefficients. Then let's look at the a's. I tend to go alphabetically. So here's an a and here's an a. Add their exponents. 3 plus 2 is 5, so you get a to the 5th. The next variable is b. So let's look at our b's. We have a b to the 1st here and a b to the 2nd here. So 1 plus 2 is 3. So b cubed. And then for our c, there's only one variable that has a c, and that's c squared. So you just bring that down, c squared. So your product, 3a to the 5th, b to the 3rd, c squared. Now let's look at a monomial times a binomial. So here we have an example of a very simple monomial times a trinomial. So you're going to use what's called the distributive property, and we're going to multiply 5 to everything inside those parentheses. So again, coefficient to coefficient, like base to like base. So 5 times x squared is just 5x squared. 5 times x is a positive 5x, so don't forget your sign. 5 times 4 is a positive 20. These are not like terms, they both have an x for their variable, but their exponents are not the same. So your answer is 5x squared plus 5x plus 20. Example 2. Again, we're going to use that distributive property and multiply the 2x squared y to everything inside the parentheses. Now this monomial is a lot more complicated than the previous one, so it's very important that you remember coefficients to coefficients, like bases to like bases. And I want to point out that this y here is a coefficient of, or exponent of 1, this y here is an exponent of 1, and that x has an exponent of 1. So 2 times 3 is 6. X squared times x, add those exponents, you get x to the 3rd. And then y to the 1st times no y, well, you just bring the y to the 1st down and don't write it to the 1st power. The next distribution would be 2 times negative 1, because technically the coefficient here is a negative 1. So 2 times negative 1 is a negative 2. X squared times no x's means we're just bringing an x squared down. y to the first times y to the first, add those exponents, you get y to the second. Now both of these terms have x's and y's, but they are not raised to the same exponent, so they are not like terms, and that's your answer. Last one on this page, example 3. So you do this on your own, and we'll see how you do. So pause the video at this point, complete your solution to example 3, and then replay the video and see if your solution is correct. Now we're going to look at a binomial times a binomial. So there are 3 different ways you could choose to multiply this binomial to this binomial. One of the first ways that you may have been taught how to multiply is something called first and then outer. I'm changing my colors. And then inner. Whoops, there we go. And then finally, last. First, outer, inner, last is known as FOIL. And let's go ahead and write those words in here. So first, outer, inner, and then last. And what those mean, they refer to the position a term is in the binomial here. So first means the first spot in each of the binomials. So each of the x's are considered first. The outer would be the outside of the binomials. So the outer would be the x and the -5. The inner is just as you would imagine. It is the inner terms. Whoops, let me erase that. Is the inner terms in the binomial. So it would be the 2 and the x. And then finally, last would be the last terms, the last spot in each of those binomials. So the 2 and the -5. And you just multiply those together. So your first term would be x times x. So that would give you an x squared. Your outer terms would be x times -5. So that would give you a -5x. Your inner terms would be 2 times x, which would be a positive 2x. And your last terms would be 2 times -5, which is -10. And then you would want to look to see, do you have any like terms? Well, both of the inner and outer terms have an x to the first power, so they are like terms. So then to combine your like terms, the x squared does not have a like term, but -5x and positive 2x make a -3x, and then the -10. So this would be the result of your foiling. Instead of foiling, you could have just done a double distribution and gotten the same result. So I'm going to erase this right here. No, I can't. Hold that thought. All right, so let's see if I can erase. I don't want that. No. There we go. Okay, so if I were just doing a double distribution, oh, my f's are still there, just ignore them. I would have taken the first term of the binomial and just multiplied it, just like we did with the monomials on the previous page, to everything in the second set of parentheses. That would have given me x times x, the x squared here, and x times -5, the -5x. Then for my second distribution, I would take the 2 times the x and the 2 times the -5. So take the second term of the binomial and multiply it to the second binomial. So the 2 times the x gives you your 2x here, and the 2 times the -5 gives you your -10. So what you can see are these two sets of double distributions, one for this first term multiplied through, and one for the second term multiplied through. That works for any polynomial. Foiling only works for a binomial times a binomial. The other way that you could do this is using a Punnett square. So we've got 4 terms all together in our binomial, 1, 2, 3, 4. So we need to have 2 here, so 2 going this way, and 2 here, 2 going this way. So I'm going to make what is called a Punnett square. You use these a lot in science. So I'm going to put the x plus 2 on one side and the x minus 5 on the other side. And then you just combine. This squared is made up of x and x. So x times x is x squared. And then this squared is made up of x times negative 5. So x times negative 5 is a negative 5x. This squared is made up of 2 times x. That's where they intersect. So 2 times x, get my right color, is a positive 2x. And the final square here is intersected by 2 and negative 5. So 2 and negative 5, or 2 times negative 5, is a negative 10. And as you can see, these correlate to the same terms here for FOIL. So you can use either one. I tend to not use the FOIL only because I want you to think of as either a double distribution like this or the Punnett square. So I'll do this one using both. So let's look at example 2. The problem with example 2 is 80% of you get the wrong answer. You see x plus 5 squared right here, and you think, oh, I'll just distribute that squared and make this x squared plus 5 squared, making it x squared plus 25. Well, that's incorrect because x plus 5 squared means that you're going to take x plus 5 and multiply it to itself twice. So if you use a Punnett square, you would put an x and a positive 5 here, an x and a positive 5 here. So in this box, you've got x times x. That gives you an x squared. And in this box, it intercepts by x and positive 5. So x times positive 5 is a positive 5x. In this box here, it's intercepted by x and 5. So 5 times x is a positive 5x. And the last box, right here, is intercepted by 5 and 5. So 5 times 5 is a positive 25. Now the only thing I don't like about the Punnett squares is it does not line up your like terms. So these right here are like terms because they both have an x to the first power. So the x squared is by itself, it doesn't have a like term. 5x plus 5x, add the coefficients, you get 10x's, and then plus the 25. If you were to use a double distribution, it would look like this. So a double distribution means I'm going to take this x and multiply it to everything in the next parentheses. So x times x gives us x squared. X times 5 gives us a positive 5x. Then for your second distribution, you're going to take the second term in that first binomial and multiply it all the way through to the second binomial. So you get 5 times x, and here's where I like that double distribution better. You get a 5x, and you want to put it underneath its like term this way. And then 5 times 5 is 25. And then you can just add the columns down. So now that you've identified your like terms, when you add the columns down, you just pay attention to coefficients. Well, there's only one term here, so you just bring it down, x squared. There are 2 terms, just add the 5s. 5 plus 5 gives you positive 10 x's, and then plus 25. And so we end up with the same answer as a Punnett square. You just use whatever you like best and whatever works well for you all the time. Example 3. So you're going to go ahead and do this problem on your own. Pay attention to coefficient times coefficient, like base to like base. I'm not going to talk as I do the problem, so pause the video at this point and try it on your own. So your answer is this, and the place where you might have made a mistake would be right here in this middle term. You've got a 1 a squared b here, or a negative 1 a squared b here. So when you had a negative 6 to a negative 1, that's where the negative 7 comes into play. Again, you could have used that Punnett square. I'm not going to go through the whole thing. I'm just going to get it prepared for you. But you could have put the 3a squared and the minus b here, and then the a squared and the minus 2b here, and then just multiplied their amounts, and you would have gotten these 4 terms here in these 4 boxes. So you should get the same answer. All right, let's look at something more complicated. This time we're going to multiply polynomials to polynomials. So let's look at example 1. You can use a Punnett square, and I'll show you on the first one, but I'm not going to do it after that. I prefer to do multiple distributions. So I'm going to start with x and multiply it to x squared. I'm multiplying like bases, so I'm going to add the exponents. This one has an exponent of 1, so I get an x cubed. Then x times a negative 5x. So I've got a 1 times a negative 5 gives me a negative 5. X to the first times this is an x to the first. I'm going to put a little 1 there. So x to the first times x to the first, add those exponents, you get x squared. I have one more distribution all the way over here. So this time I've got a coefficient of 1 times 4. That gives me a positive 4. And then x times nothing just means I tack the x on. So there's my first distribution. All I have left is to distribute this 2 into everything here. So piece by piece, so 2 times x squared is 2x squared. It has a like term with negative 5x squared. So I'm going to put the positive 2x squared directly below it. That way you collect your like terms. It's much easier. Then we're going to take 2 times negative 5x. 2 times negative 5 is negative 10. And then the x you just tack on. It's a like term to the 4x, so line it up underneath. And then finally, 2 times 4 is a positive 8. So then draw your line and add down. You get x cubed. A minus 5 and a positive 2 gives you a minus 3x squared. A positive 4 and a minus 10 gives you minus 6x plus 8. The setup for the Punnett square. Since you have a 2 by 3, your Punnett square would need to be 2 by 3. So here's your 2, and here would be your 3. So you would put your x plus 2 here, and then you would put your x squared minus 5x, and then your plus 4 here. And then just multiply where the boxes intersect. And you will get these identical things here. Again, the problem is your like terms don't necessarily line up, and you can easily make a mistake. So I do prefer this method. All right, example 2. I'm going to do a double distribution. If you want to do a Punnett square, be my guest. So for the first distribution, coefficient to coefficient, like base to like base. So 3 times negative 2 is negative 6. X to the first times x cubed, add those exponents, you get x to the fourth. 3 times 5 is a positive 15. X to the first times x to the first, add those exponents, you get x squared. 3 times negative 6 is negative 18. It doesn't have an x, so just tack on the x to the first. Then do your second distribution. Negative 4 times negative 2 is a positive 8, and it's going to be an x cubed. There's no x cubed here, so give it its own column, so positive 8x cubed. Then our next distribution, negative 4 times 5 is negative 20. Tack on the x. It's going to line up here, negative 20x. Negative 4 times negative 6 is a positive 24. It doesn't have a like term, so give it its own column. So then draw your line and add. Negative 6x to the fourth plus 15x squared. A negative 18 and a negative 20 is a negative 38x plus 8x cubed plus 24. This polynomial is not in standard form. If you were to put it into standard form, this term would come first because it's the highest degree term, then this term, then this term, then this one, and finally the constant. The last example completely. So on this one, I would let you do it on your own, and you can do it on your own. You can pause if you want to, but before you do, make sure they understand that x minus 2 cubed means x minus 2 times x minus 2 times x minus 2. So what I'm going to do is multiply these two together first. So I'm going to keep the first x minus 2, but then I'm going to go and do a double distribution here. So I've got x times x, which is x squared, then x times negative 2, which is a negative 2x. Then I got my second distribution, negative 2 times x, line that up underneath there, negative 2x, and then negative 2 times negative 2 is a positive 4. Collect your like terms. We actually have an x minus 2 times x squared minus 4x plus a 4. Now you can multiply the third x minus 2 in. So now you're going to do another double distribution. So I'm going to put a line through here. So my first distribution, I'm going to use a different color. So I'm going to use x times x squared. So remember that's x to the first. So add those exponents, you get x cubed. The coefficient in front of x is a 1. So 1 times negative 4 is negative 4. X to the first times x to the first, add those exponents, you get x squared. Finally, you've got a 1 times 4 gives you a positive 4. X times no x gives you an x to the first. Then we're going to distribute the negative 2. So negative 2 times x squared lines up with a negative 4x squared, so you've got a negative 2x squared lining up with that 4x squared. Then negative 2 times negative 4 is a positive 8x, so line it up underneath x term here, positive 8x. And then finally, negative 2 times positive 4 is a negative 8. So our ultimate final answer is going to look like this. So add the columns down, just the coefficients. You've got x cubed, a minus 4 and a minus 2 is a minus 6x squared. That variable string does not change. A positive 4 and a positive 8 is a positive 12x, and then minus 8.